What was there before the Big Bang? This audiobook explores Michio Kaku's ideas about the origin of the universe, from string theory to the possibility of a multiverse where ours is just one among many. More than a scientific question, the origin of the cosmos is, for Kaku, a doorway to understanding the deepest aspects of reality and our place within it. In this context, one name resonates strongly in the field of science communication: Michio Kaku. This theoretical physicist and communicator has dedicated his life to unraveling the secrets of the universe, becoming a bridge between the complexity of science and the curiosity of the public. His ability to explain complicated concepts in an accessible way has inspired millions to look up at the stars and question what lies beyond our world. The story of Michio Kaku is, in itself, a captivating tale. From his childhood, Kaku showed an insatiable interest in science and physics. Imagine a child who, instead of playing with conventional toys, spent his time building rocket models and dreaming of traveling through space. This passion led him to become one of the most influential physicists of our time. But what motivates him to share his knowledge? The answer is simple: the desire for everyone to peek through the window of the universe and see what he sees. As we delve into the topic of the origin of the universe, it is impossible not to mention the Big Bang theory. This revolutionary concept tells us that everything we know began from a monumental explosion. But what does this really mean? Imagine a balloon being inflated. At first it is small, but as you inflate it, it expands, and that is what happened with our universe. Everything began at an extremely dense and hot point, and since then it has been expanding. This simple act of inflating a balloon helps us visualize how our reality was formed. The expansion of the universe is not just a fact, but a phenomenon that changes the way we understand the cosmos. When we look up at the sky and see the star, we are seeing the past. The lights that shine in the darkness have traveled millions of years to reach our eyes. But what if I told you that the universe is still expanding? Every day, every second, galaxies are moving away from each other, as if they are fleeing from an immense cosmic engine. This leads us to ask, where is all this going? One of the most intriguing theories that has emerged in this context is cosmic inflation. This idea suggests that just after the Bang, the universe experienced a period of extremely rapid expansion. Imagine that, in the blink of an eye, the universe doubled in size over and over again. This rapid expansion not only explains the uniformity we observe in the universe, but also raises more questions. If everything expanded so quickly, what was there before that inflation? As we delve deeper into these questions, we encounter concepts that may seem perplexing, such as dark matter and dark energy. These mysterious entities make up most of the universe, but curiously, we cannot see or touch them. They are like the air we breathe. We know they are there, but we are not always aware of their presence. So how do we know they exist? The answer lies in how they affect the behavior of galaxies and the light that reaches us from them. Symmetry in physics also plays a crucial role in understanding the origin of the universe. Often, nature surprises us with its beauty and order, and this symmetry is a reflection of the fundamental laws that govern the cosmos. But why is symmetry important? Think of a puzzle. When all the pieces fit together harmoniously, the final result is a perfect image. This is how physics works. Every law and every particle has its place in the grand scheme of the universe. As Kaku guides us through the complexities of the cosmos, he also presents string theory, an idea that attempts to unify the fundamental forces of nature. Imagine that subatomic particles are like tiny vibrating strings. According to this theory, the way they vibrate determines the properties of matter. But what implications does this have for our understanding of the universe? If everything is based on strings, we might be more connected than we ever imagined. Moreover, the notion of multiverses becomes a fascinating topic. What if our universe is not the only one? The idea that multiple universes exist, each with its own laws and realities, is both exciting and perplexing. If one universe can give rise to life, how many more might exist in this vast web of realities? The paradox of time is also intertwined with our quest for answers. What is time really? Many perceive it as a straight line moving forward, but Kaku invites us to think of time as a dimension that can be flexible and curved. This understanding could change our view of the past, present, and future, leading us to question whether there is truly a beginning or an end. Finally, we reflect on how the Big Bang not only gave rise to the universe but also created time itself. This idea may be difficult to grasp, but what if I told you that time, as we know it, began at that moment? What does this mean for our existence and our search for meaning? Throughout this journey, we have explored the laws of physics that allowed for the creation of the universe. Kaku, with his unique style, leads us to reflect on how these laws are not just formulas on a blackboard, but the very rules that govern our daily lives. But what if science and spirituality could coexist? Could there be a purpose behind the vastness of the cosmos? As we prepare to dive into these topics, the invitation is clear. Let's keep exploring. The universe is a vast ocean of mysteries and wonders, and each discovery brings us a little closer to understanding who we are and where we come from. Curiosity is the first step to unraveling the unknown, and this journey is just beginning. In the vast universe of science, Michio Kaku stands out as a beacon of knowledge and curiosity. But who is this theoretical physicist and science communicator? To understand his impact, it is essential to explore his life and career. Born in 1947 in San Jose, California, Kaku showed an unwavering interest in the cosmos from a young age. His childhood curiosity led him to build a particle accelerator in his garage, a project that was not only ambitious, but also foreshadowed his future in the world of physics. His education was equally impressive. Kaku attended Harvard University, where he earned his bachelor's degree in physics. He then moved to the California Institute of Technology to pursue his PhD. There, he immersed himself in the world of theoretical physics, specializing in string theory, a field that seeks to explain how the fundamental particles of the universe work. But beyond being a distinguished academic, Kaku has become an excellent communicator, bringing the complexities of science to a broader audience. Through his books, lectures, and television programs, he has made complex topics accessible and fascinating. The question many ask is, why is science communication so important? Kaku firmly believes that science does not belong solely to laboratories or universities. It is a common heritage of humanity. By sharing his knowledge, he seeks to inspire new generations to be curious and to question the world around them. In a time when information is abundant, the ability to distinguish between what is true and what is false becomes crucial. Kaku's work is vital for cultivating critical thinking in society. One of Kaku's most interesting contributions is his focus on string theory. This theory, which posits that subatomic particles are not points but vibrating strings, offers a fascinating view of the universe. Kaku has explored how this idea could not only unify all the forces of nature, but also answer some of the deepest questions about the origin of the universe. But what makes this theory so special? Essentially, it suggests that reality is much more complex and beautiful than we can imagine. In addition to his academic work, Michio Kaku is a tireless advocate for science in the media. His charismatic style and ability to simplify complex concepts have made many see him as a bridge between the scientific world and the general public. Through documentaries and television programs, he has brought the mystery of the universe to the screens of millions, and this raises an intriguing question. How does Kaku manage to make science seem so exciting? His passion for knowledge is contagious, and his storytelling ability brings even the most abstract topics to life. Kaku has also addressed current issues in the scientific realm, such as artificial intelligence and the possibility of life on other planets. His vision is not limited to physics. He also delves into the ethics and implications of science in society. He serves as a reminder that science does not exist in a vacuum. It is intrinsically linked to human experience and our aspirations as a species. This leads us to question, what role does science play in our future? The answer may be as complex as the universe itself. Another facet of his work is the dialogue between science and spirituality. Kaku has explored how scientific advances can influence our understanding of the divine and the transcendent. This multi-dimensional approach reflects his desire to unite different forms of knowledge. In a world where science and religion often seem to be in conflict, Kaku proposes a space where both can coexist and enrich each other. Throughout his career, Michio Kaku has written several books that have been acclaimed by both critics and readers. Works such as The Physics of the Future and The Universe in a Nutshell are examples of his ability to connect complex ideas with everyday life. Through these works, Kaku invites everyone to imagine a future where science and technology enhance our lives in ways we have yet to comprehend. What future truly awaits us? The answer lies in our hands and in how we choose to explore and understand the world. In summary, the figure of Michio Kaku is not only a testament to the power of curiosity and knowledge, but also represents a bridge between science and society. His ability to communicate complex ideas in an accessible manner has inspired millions to look to the stars and question their place in the universe. The science, as he presents it, is not just a field of study, it is a shared adventure into the unknown. Who knows what discoveries the future holds for us? What is clear is that the quest for answers will continue, and Kaku, with his passion and dedication, will keep illuminating the way. The Big Bang Theory is one of the fundamental pillars of modern cosmology. If you think about it, what image does the concept of a big explosion evoke? most of us might imagine an explosion, a kind of cosmic fireworks. But in reality, the Big Bang was not an explosion in the conventional sense. Instead, it was the moment when the universe began to expand from an extremely hot and dense state. But how do we know this? What evidence leads us to accept this theory? One of the first clues comes from the observation of light from distant galaxies. When we look up at the sky, we are not just seeing stars, we are looking back in time. The light that reaches us from these galaxies has travelled for billions of years, and what we have discovered is astonishing. Galaxies are moving away from us. What does this mean? It means that the universe is expanding. If we go back in time, we can imagine that at the beginning everything was concentrated in a single point. How did that point form? That is one of the questions we ask as we explore the Big Bang. The famous Hubble's law states that the farther away a galaxy is, the faster it is moving away from us. This phenomenon is comparable to an inflating balloon. Imagine drawing dots on the surface of a balloon. As you inflate the balloon, those dots move away from each other. This is how the universe behaves. As it expands, galaxies separate. But what happened before that initial moment? What was there before the Big Bang? These are questions that still intrigue us. Scientists have formulated various theories to address the state of the universe before the Big Bang, but the truth is that it remains a deep mystery. Some suggest that there might have existed a state of pure energy, while others propose the possibility that the universe has gone through cycles of expansion and contraction. However, what we really know is that at that instant of the Big Bang, the laws of physics as we understand them began to take shape. Imagine that in an instant the universe not only began to exist, but also started to experience a dizzying expansion. The first moments after the Big Bang were like a torrent of energy and particles, a kind of primordial soup. But how did the elements we know today, like hydrogen and helium, form? During the first minutes of the universe's life, physicists believe that nucleosynthesis occurred, a process in which the first atomic nuclei were formed. As the universe continued to expand and cool, it began to allow the formation of atoms. These atoms in turn grouped together to form the first stars and galaxies. The light we see today from those stars is an echo of those early moments. Isn't it magical to think that when we look at the sky, we are seeing the history of our universe written in light? The Big Bang theory is also supported by cosmic background radiation, an echo of the heat that remained after the initial explosion. This radiation is like a signature of that first moment, full of information about the temperature and density of the primitive universe. Imagine a campfire that, even when it goes out, leaves residual heat. That cosmic radiation is the residual heat of the Big Bang, and studying it gives us clues about what the universe was like when it was young. Over the years, the Big Bang theory has been subjected to multiple tests and observations, and with each step it seems to gain more support. But does this mean it is completely resolved? The answer is no. There are still many unanswered questions that lead us to explore more deeply. For example, what are dark matter and dark energy, and how do they relate to the Big Bang? The Big Bang theory not only tells us how the universe began, but it also offers us a framework to understand how it has evolved. It connects us with philosophical questions about our place in the cosmos. What does it mean to be part of a universe that began with a big explosion billions of years ago? The implications are profound and invite us to reflect on the meaning of existence itself. In summary, the Big Bang Theory is more than just a simple explanation of the origin of the universe. It is a window into our past, an invitation to explore the unknown, and a reminder that the universe is a place full of mysteries waiting to be discovered. As we continue to investigate and learn, we may find ourselves a little closer to understanding not only how everything began, but also where we are headed in this vast cosmos. And so, the search for the origin of the universe continues, always with new questions and possibilities waiting to be explored. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The expansion of the universe is a fascinating phenomenon that invites us to reconsider our position in the cosmos. How is it possible that everything we know is moving away from us? This enigma dates back to the early observations of astronomer Edwin Hubble in the 20th century, who discovered that galaxies were not only countless, but also moving away from us at astonishing speeds. This leads us to an intriguing question. If galaxies are moving away, does it mean they were once together? The answer to this question takes us to the heart of the Big Bang Theory, which suggests that the universe began as an extremely hot and dense point about 13,800,000,000 years ago. Since then, it has been in a constant state of expansion, like a balloon inflating as we blow air into it. But what drives this expansion? Is it a mysterious force that we do not fully understand? As we delve into this topic, we find that the expansion of the universe is not simply a phenomenon of distancing, but a revelation about the very nature of reality. Each galaxy we observe in the sky is like a beacon telling us a story about the past. The distances between them are constantly changing, which means the universe is not static. It is a dynamic place in constant transformation. But who measures these distances, and how do we know they are really increasing? Astronomers use spectroscopes to study the light emanating from galaxies. When they observe the light spectrum, they notice that certain wavelengths are shifted toward the red, a phenomenon known as redshift. This effect occurs when an object is moving away from us, similar to the sound of a siren changing pitch as it moves away. This is how we can assert that the universe is expanding, but it also leads us to a deeper reflection. What is the ultimate fate of this expansion? As the universe expands, the temperature of space cools. This raises new questions. Does this mean that the universe will cool down to a state of freezing? Or is there a balance that will be reached in the future? The expansion affects not only galaxies, but also the matter and energy that make up the cosmos. In fact, the expansion is driven by a mysterious form of energy known as dark energy, which constitutes about 70% of the universe. This dark energy is one of the great mysteries of modern cosmology. What is it really? Why does it seem to be accelerating the expansion of the universe? The idea of expansion also leads us to consider the concept of time. As the universe expands, time itself seems to play a crucial role. But how are the expansion of the universe and time related? It is as if time and space are intertwined in a cosmic fabric that continuously unfolds. As the universe expands, the events occurring within it also develop and evolve. The expansion of the universe also confronts us with the notion of finitude and infinity. Is it possible that the universe is infinite in its extent but finite in its age? Or could there be a limit to the expansion that will eventually reverse? The idea that the universe could collapse upon itself in the distant future is a concept that invites speculation and philosophical reflection. All of this leads us to ask, what is humanity's role in this vastness? It is true that the expansion of the universe reminds us of how small we are compared to the cosmic immensity. However, it also invites us to marvel at being part of this vast stage. Human curiosity has driven many scientists to explore the implications of expansion. Are we the only ones asking these questions? The search for answers propels us to look to the stars to investigate and to dream of what might lie beyond our world. With each discovery and every advancement in technology, we come closer to understanding how the universe works. Space missions, advanced telescopes, and computer simulations are just some of the tools we use. But what is more fascinating is that each answer generates new questions. How much more can we learn about the universe before our own questions lead us to a new horizon of exploration? Ultimately, the expansion of the universe is not just a physical phenomenon, but a reminder of our own quest for knowledge. It connects us with past generations who looked at the sky and wondered about their place in the cosmos. The expansion of the universe is an endless journey, a constantly evolving narrative that invites us to keep exploring and keep asking. And so, as we venture into this vast cosmos, we discover that each answer leads us to new questions, keeping alive the flame of curiosity that drives us to understand our place in the universe. What if I told you that at the very first moment of the universe, everything we know was concentrated in an incredibly small and hot point? This concept, known as cosmic inflation, is fundamental to understanding how our universe began. But what does cosmic inflation really mean? And why is it so important in modern cosmology? Imagine that the universe is a balloon. When you inflate it, its surface expands rapidly, and what was once very close quickly moves away. Cosmic inflation resembles that process, but instead of a balloon, we are talking about all of space and time. However, this expansion not only refers to space, but also to how galaxies and structures in the universe have formed and evolved over billions of years. To understand cosmic inflation, we need to go back in time. Just after the Big Bang, the universe was so dense and hot that the laws of physics as we know them did not apply. At that moment, it is believed that an exponential expansion occurred in less than a fraction of a second. But why did this happen? The answer is still under study, but scientists have proposed that a form of energy, known as vacuum energy, may have been responsible for this phenomenon. Cosmic inflation not only explains how the universe expanded, but also resolves several problems that the Big Bang model had. For example, why is the universe so homogeneous and uniform on a large scale? Without inflation, we could not explain how distant regions of the universe have similar properties despite being separated by vast distances. Through inflation, it is suggested that small fluctuations in the density of the early universe became the structures we observe today: galaxies, clusters, and superclusters. It's as if, when inflating a balloon, some parts expand more than others, creating wrinkles and bulges. These irregularities are fundamental, as they are the seeds from which everything we know sprouted. However, the concept of cosmic inflation raises intriguing questions. If the universe expanded so rapidly, what was there before that expansion? Did something exist in that initial moment, or did everything come to be from an absolute void? Some scientists suggest that the universe could be part of an infinite cycle of expansion and contraction, while others believe there could be multiple universes, each with its own inflationary history. It is fascinating to think that, in such a brief moment, the fundamental laws governing our universe were established. Cosmic inflation provides a framework for understanding how particles formed and how they interact. This leads to an essential question: could there be other universes, each with different physical laws? The idea of multiverses intertwines with inflation, suggesting that what we know is just a small part of a vast and complex cosmos. So how do you test something as abstract as cosmic inflation? Scientists have been searching for evidence through astronomical observations and experiments in space. One of the most promising methods is studying gravitational waves, which could offer clues about that early epoch of the universe. Imagining that the echo of inflation still resonates throughout the cosmos is undoubtedly a captivating idea. Understanding cosmic inflation also leads us to consider the nature of time itself. If time began with the Big Bang, what does that mean for our perception of time? Inflation, in this context, adds another layer of complexity to our understanding of how time and space are intrinsically intertwined. Exploring cosmic inflation is not only a journey into the past, but also an invitation to reflect on our place in the universe. If the universe is expanding and has gone through stages of inflation, what does that tell us about our future? Theories of eternal expansion suggest that the universe could continue to expand indefinitely. In summary, cosmic inflation is a concept that not only helps us understand the origin of the universe, but also poses profound questions about existence itself. As we continue to explore and discover, each new piece of the puzzle brings us closer to unraveling the secrets of our cosmos. Let's imagine for a moment that, in the end, we are part of a much larger and more complex story than we could have ever imagined. Cosmic inflation is just one chapter in this tale, but it is one that allows us to dream and question our place in the vast universe. As we move forward, curiosity and the pursuit of knowledge drive us to keep exploring, because after all, the universe has many more surprises in store for us. Have you ever stopped to think about what really makes up our universe? Most of us are familiar with the matter that surrounds us, the stars, the planets, and even ourselves. However, there are two concepts that seem hidden in the shadows of the cosmos: dark matter and dark energy. What are they really? And why are they fundamental to understanding our universe? Dark matter presents itself as an intriguing enigma. Imagine you're in a dark room searching for a lost object. Even though you can't see the object, you know it's there because you can feel its presence by bumping into other objects, or by seeing how the light moves around it. Similarly, although we cannot see dark matter, its effects are visible through how galaxies behave. It is estimated that dark matter makes up about 95% of the total matter in the universe. How can something so abundant be so elusive? To understand it better, let's think about how galaxies rotate. Imagine you're watching a carousel. If you only look at the horses and do not consider the motor that drives it, you won't understand why it spins so fast. Dark matter acts like that hidden motor, providing the necessary gravity that holds galaxies together. Without it, the stars at the edges of galaxies would move differently, and our understanding of the cosmos would crumble. On the other hand, dark energy is even more puzzling. This phenomenon is responsible for the acceleration of the expansion of the universe. Imagine you're inflating a balloon. At first, it seems like the air is entering steadily, but at some point you feel the balloon expanding more rapidly. Dark energy is like that air pushing the balloon, causing the expansion of the universe not only to continue but to do so at an accelerated rate. But what exactly is this dark energy? Scientists have proposed several theories. Some suggest that dark energy is a property of space itself, a kind of vacuum that generates negative pressure. Other theories indicate that it could be a form of energy that we have not yet fully understood. The question we all ask is, will we ever be able to see and understand this dark energy that makes up most of the universe? The relationship between dark matter and dark energy is fundamental. Imagine a great cosmic chess game where the pieces are galaxies and the forces are dark matter and dark energy. While dark matter acts like the rules that guide the movement of the pieces, dark energy is the invisible player that decides when and how the board will expand. Together, these two forces shape the destiny of the universe. As the scientific community continues to investigate, more questions arise. What if we discover that dark matter is not what we think? What if dark energy has even stranger properties than proposed? Each new discovery could radically alter our understanding of the cosmos. Human curiosity drives us to keep exploring, to seek answers to these mysteries. Current experiments are designed to detect these forces, from telescopes observing the light of distant galaxies to particle accelerators searching for dark matter. Science is on a constant quest. Each technological advance brings us one step closer to unraveling these secrets. But what will happen when we finally manage to see the invisible? The implications of understanding dark matter and dark energy are enormous. They could change our view of time and space, and perhaps even of existence itself. If we manage to comprehend the nature of these forces, we might also glimpse the future of the universe. Are we destined to keep expanding forever? Or will there come a moment when everything collapses? The story of dark matter and dark energy is not just a scientific matter, it is also philosophical. It challenges us to question our understanding of reality and our place in the cosmos. What does it mean to be human in a universe where most is invisible? These questions take us on a profound journey into exploring our own existence. In his quest to understand the universe, Michio Kaku has also addressed these topics. For him, the study of dark matter and dark energy is a crucial step in the search for a unified theory that explains all the forces of nature. Kaku invites us to imagine a future where the mysteries of the universe are no longer dark, but illuminated by knowledge and curiosity. Dark matter and dark energy are more than abstract concepts. They are gateways to a universe of possibilities. As we advance in our understanding, each answer generates new questions, and that is the true spirit of science. In this vast cosmos where the visible is only a small fraction of reality, the pursuit of knowledge continues, driven by our insatiable curiosity. So, what discoveries does the future hold for us? Only time will tell, and we will be here, ready to explore. Symmetry is a fascinating concept that lies at the heart of physics. Have you ever stopped to think about why things are the way they are? Symmetry offers us answers, and at the same time raises intriguing questions. In nature, we find symmetry in many places, from the shape of a flower to the structure of crystals. But what does this have to do with the origin of the universe? First, it is important to understand that symmetry in physics is not just an aesthetic issue. It is a powerful tool that scientists use to understand the laws that govern our universe. Imagine that the laws of physics are like a card game. Symmetry is the set of rules that tells us how we can play that game. Without symmetry, it would be like playing without rules, making everything unpredictable. Symmetry also plays a fundamental role in the conservation of certain physical properties. For example, the symmetry of energy and time tells us that the total energy in a closed system remains constant. This is similar to having balance on a scale. If one side is loaded, the other must compensate to maintain stability. Without symmetry, nature could not conserve these properties, and the universe would be a chaotic place. Have you ever wondered why fundamental particles like electrons and quarks exist? The answer lies in symmetry. In physics, each type of particle has a partner that shares similar properties, known as particle symmetry. This suggests that, at a fundamental level, there is an underlying pattern in nature that organizes these particles into families. Without this symmetry, it would be difficult for scientists to predict how particles behave in different situations. As we delve deeper into symmetry in physics, we find that there are different types. One of the most intriguing is gauge symmetry, which is fundamental to unified field theory. This theory seeks to explain how the fundamental forces of the universe, such as gravity, electromagnetism, and the nuclear force, are interconnected. Gauge symmetry is like an invisible thread that connects all these forces, allowing them to interact with each other. Symmetry breaking is another key concept that may seem contradictory. Sometimes the universe behaves unexpectedly, and symmetries can be broken. Imagine you have a perfectly balanced puzzle, but one day a piece falls out. Now, the puzzle no longer has the same symmetry. In physics, this can lead to new particles and forces, helping us understand phenomena like particle mass. This symmetry breaking is essential to explain why some particles have mass and others do not. Symmetry also leads us to think about the very nature of time and space. What if time were symmetrical? In theory, that would mean we could move forward and backward in time just as we can move through space. However, the reality is that time has a direction. It always moves forward. This asymmetry in time suggests that there is something intrinsic in our universe, that pushes events to unfold in a particular way. What implications does symmetry have for the origin of the universe? When thinking about the Big Bang, it is crucial to understand that in its early moments, the universe was extremely symmetrical. However, as it expanded and cooled, those symmetries began to break down, giving rise to the variety of particles and forces we know today. This process is like a beautiful cosmic dance, where symmetries unravel and give way to the diversity of the universe. Symmetry also plays a role in the search for a unified theory that integrates all the forces of nature. Many scientists, including Michio Kaku, believe that there is an underlying theory that can explain everything from gravity to quantum mechanics. Symmetry is the path that can lead us to this unification. It is like searching for the master design behind a complex tapestry, where each thread has its place and function. Moreover, symmetry is not only found in physics but also in nature itself. We observe symmetry in biology, in the growth of plants, and in the shape of animals. These similarities suggest that there are universal principles governing both the cosmos and life on Earth. The connection between physics and biology leads us to consider the possibility that symmetry is a fundamental characteristic of reality. Reflecting on symmetry, we might ask ourselves, what does it mean for us, as human beings, to be part of a universe that follows these rules? Symmetry not only organizes the cosmos, but also offers us a sense of order and beauty. It reminds us that despite our differences and inequalities, there is an underlying pattern that connects us all. In summary, symmetry is a key concept that helps us unravel the mysteries of the universe. It shows us that there is order in chaos, and that nature follows rules that, although sometimes seem complex, are ultimately accessible. As we continue to explore the cosmos, symmetry will remain a guide that helps us understand our place in this vast and mysterious universe. String theory is a fascinating attempt to unify all the forces of nature into a single framework. But what does this really mean? To understand it, it is helpful to imagine that the universe is like a vast ocean, where each wave and current represents a fundamental force. In this ocean, string theory acts as a guiding thread, uniting these waves into a single symphony of existence. At the heart of string theory is the idea that subatomic particles, which we traditionally think of as points, are actually vibrating strings. These strings are incredibly small, so small that we cannot see them even with the most powerful microscopes. But how does this affect our understanding of the universe? Each vibration of these strings represents different particles, and thus, the way they vibrate determines the type of matter we perceive around us. Isn't it amazing to think that, at the core of matter, there are vibrating melodies creating this symphony of the cosmos? String theory not only seeks to describe particles, but also the forces that bind them. For example, did you know that gravity, that force that keeps us grounded, can also be explained through these strings? To understand it better, imagine a musical instrument. When you play a note, the vibration generates waves that propagate. Similarly, vibrating strings create waves that manifest as the forces interacting in the universe. This connection between vibration and force is a revolutionary concept that could change our view of physics. With string theory, intriguing questions arise. If everything is made of vibrating strings, what about black holes? They were thought to be impenetrable enigmas in the universe. However, string theory offers a new perspective. These holes could actually be a special type of vibrating string. This suggests that even the darkest mysteries of the cosmos may be part of a beautiful underlying harmony. One fascinating aspect of string theory is that it proposes additional dimensions. While we are accustomed to the 3 dimensions of space and 1 of time, the theory suggests that there are more dimensions that we cannot perceive. Why would we have extra dimensions? Imagine a crumpled piece of paper. From a distance, it appears 2-dimensional, but as you get closer, you can see that it actually has a 3rd dimension. The additional dimensions in string theory could be similar, hidden but essential to the structure of the universe. Now, if these strings are vibrating in a space of more dimensions, does that mean there are different realities coexisting? This idea is fascinating. Imagine that each vibration of a string in an additional dimension creates a different universe. Thus, the concept of multiverses intertwines with string theory, suggesting that we might be just a small part of a vast cosmic landscape filled with alternative realities. String theory also attempts to address problems that have challenged physicists for decades. For example, the reconciliation between quantum mechanics and general relativity has been a battle. String theory offers a possible solution by integrating both theories into a broader framework. Isn't it extraordinary to think that we might be on the verge of unraveling one of the greatest mysteries of physics? However, string theory is not without its criticisms. Some scientists question its ability to be empirically tested. In a world where evidence is key, how can we accept a theory that eludes our observational capabilities? This leads us to a profound reflection on the nature of science itself and how we advance in the pursuit of truth. The beauty of string theory lies in its mathematical elegance. Many physicists are drawn to the poetry of its equations, which seem to dance in perfect harmony. But how much of this beauty is real, and how much is just a play of numbers? Science sometimes feels like a delicate balance between art and logic, and string theory is a brilliant example of this phenomenon. In the context of the origin of the universe, string theory suggests that the initial conditions of the Big Bang may have been influenced by these vibrating strings. This approach could offer answers to fundamental questions about how and why everything began. If the vibration of the strings was the spark that ignited the fire of the cosmos, then each of us might be connected to that primordial melody. As we delve into the study of string theory, it is inevitable to wonder about the role of consciousness in all of this. Could we be in some way an extension of those vibrations? The idea that our existence is intertwined with the very fabric of the universe raises fascinating questions about the nature of life and consciousness. The quest for unification through string theory is not just an intellectual exercise. It is a journey toward understanding our place in the cosmos. If we manage to unravel the secrets of these strings, we could be one step closer to understanding the true origin of the universe. Science and philosophy intertwine on this path, taking our reflections beyond the physical into the metaphysical. Finally, string theory is not just a theory. It is a call to curiosity. It invites us to explore the unknown, to question what we think we know, and to marvel at the complexity of the universe. In this journey, every question and every discovery brings us a little closer to the essence of existence itself. The dance of the strings continues, and we are part of this cosmic symphony. Have you ever considered that our universe might not be the only one? The idea of multiverses has captured the imagination of scientists and philosophers alike. Imagine a vast ocean of universes, each with its own physical laws, realities, and possibilities. This notion, which may seem strange or even fantastic, is a topic that renowned theoretical physicist Michio Kaku approaches with enthusiasm and curiosity. Kaku invites us to think beyond the boundaries of our universe. What if there are other parallel universes, perhaps with different versions of ourselves? This idea is not just part of science fiction. It is based on serious scientific theories. The notion of multiverses arises from the interpretation of some fundamental theories, such as quantum mechanics and cosmic inflation. Quantum mechanics, for example, suggests that subatomic particles do not have a defined state until they are observed. This principle has led some scientists to propose that every time a decision is made or an event is observed, the universe splits into multiple paths, creating a series of alternate universes where every possible outcome occurs. Thus, in one universe you might have chosen a different career, while in another you could be living in a completely different world. Cosmic inflation, on the other hand, is a theory that explains how the universe expanded exponentially in fractions of a second after the Big Bang. This expansion not only created the space we know, but could also have led to the creation of multiple bubbles or universes throughout a vast multiverse. Each bubble could have its own characteristics, laws, and dimensions. Can you imagine a universe where gravity is stronger or where time flows faster? The possibility is fascinating. Kaku also mentions the importance of string theory in the discussion of multiverses. This theory suggests that subatomic particles are actually vibrating strings in additional dimensions. According to this interpretation, the different modes of vibration of these strings could give rise to distinct universes, each with its own physical properties. In this context, the multiverse becomes a natural scenario in which infinite variations of universes can exist. However, an intriguing question arises. How can we know if these parallel universes really exist? The answer is not straightforward. Often, science advances through observation and experimentation, but in the case of multiverses, scientists face a unique challenge. If the universes are completely independent of our own universe, we may never have the ability to observe them directly. Nonetheless, some argue that traces of these universes could be present in our reality. For example, during the expansion of the universe, some features of the cosmos might have been influenced by interactions with other bubbles of universes. This opens a path for scientists to seek indirect evidence supporting the existence of multiverses. A fascinating idea that arises from this discussion is the possibility that, in some of these universes, the laws of physics are so different that life as we know it could not exist. Imagine a universe where oxygen is not the vital element we know, or where the chemistry that sustains life is completely different. What forms of life could exist under such radical conditions? Moreover, the concept of multiverses has profound philosophical implications. If there are infinite universes, each with different outcomes, what does that mean for our decisions and our reality? The notion that each choice creates a new reality can lead to questioning the nature of free will. Are we really making choices, or are we simply following a path that has already been laid out in one of the many universes? As Kaku explores these ideas, he also raises questions about purpose and existence. If there is an infinite number of universes, what is our place in this vast scheme? Is there a purpose behind our existence, or are we simply one of many variations in a sea of realities? Science and philosophy often intertwine in this discussion. The quest for answers about the multiverse can lead us to reflect on our role in the cosmos and how we understand ourselves in relation to everything around us. Curiosity about the multiverse is not just an intellectual exercise, but an exploration of the very nature of existence. Ultimately, the idea of the multiverse invites us to expand our minds and consider what we have yet to comprehend. Like Kaku, we must maintain our curiosity and desire to explore. The universe may be grander and more complex than we have ever imagined, and each theory, each question, brings us a little closer to unveiling the secrets of the cosmos. In this journey, the exploration of the multiverse is just one of the many doors we can open toward understanding the origin of our universe and perhaps all the universes that exist. How many times have we reflected on time? That measure that seems so simple yet is actually one of the deepest mysteries of the universe. In the context of cosmology and Michio Kaku's theories, time is not just a linear concept that moves from past to future. What if I told you that time itself was born with the Big Bang? This idea, although surprising, challenges our traditional understanding of chronology. Time, as we know it, did not exist before the Big Bang. Before that great explosion, the universe was condensed into a point of infinite energy, where even the notion of time made no sense. In this scenario, time began to count from the moment the universe started to expand. To conceptualize it, imagine a clock that only starts ticking when it is activated. Thus, the Big Bang was the moment when the countdown of time began. But what does this mean for us? If time began with the Big Bang, what implications does this have for our daily lives? The answer can be unsettling. It forces us to reconsider our relationship with time. It is not just a resource we use to schedule activities or remember events. It is a fundamental dimension of the universe. Without time, there are no changes, no evolution, and ultimately, no life. The question that arises is there something beyond time? Could one conceive of a universe where time does not exist? According to Kaku, the answer is yes. In string theory, which explores additional dimensions, time could be just one of the many dimensions that make up our reality. This leads us to think about the possibility of realities where time flows differently, or even does not flow at all. Imagining a universe without time can be disconcerting. However, it is essential for understanding how ours came to be. In this sense, Kaku suggests that time is an illusion, a projection of the complexity of the universe. Just like when we watch a movie, the moving images give us the illusion of a story, but in reality, each frame is static. Thus, time could be just a set of moments that we perceive sequentially. This raises the intriguing question: could there be a before the Big Bang? If time did not exist before that event, then the notion of before loses its meaning. The universe, as we know it, began at that instant, and everything that came after is the development of what was already contained in that initial explosion. This idea invites us to contemplate the origin of everything we know, and to blur the boundaries between the past, present, and future. The relationship between time and the universe also leads us to consider the nature of destiny. If time is a straight line that moves forward, does that mean everything is predetermined? Kaku encourages us to explore the idea that although time flows in one direction, the universe is complex enough to allow for multiple possibilities. Every decision we make could, in theory, be part of an endless tapestry of coexisting realities. The paradox of time is also found in the concepts of cause and effect. If time is a consequence of the Big Bang, how does this affect our understanding of how events occur? Causality is one of the cornerstones of science, but if time is malleable, then our ideas about how events unfold may be more flexible than we think. In modern physics, time has become a topic of debate, and some theories suggest that time could behave in surprising ways. For example, in certain contexts, such as quantum mechanics, time may not be a constant but something that can be manipulated. This opens up a range of possibilities that challenge our most entrenched perceptions. It is fascinating to think that our understanding of time could be evolving. Current research, driven by physicists like Kaku, seeks to unravel the mysteries of temporality and its connection to the very structure of the universe. Could it be that in the future we come to better understand how time and space intertwine? Perhaps we will discover that time is not just a simple thread that connects events, but a complex fabric that interacts with matter and energy in ways we have yet to imagine. The exploration of the nature of time also leads us to questions about existence and meaning. If time is an illusion, what does this mean for our lives? Kaku suggests that our experiences, memories, and aspirations are part of a narrative that may transcend time. This vision invites us to seek a purpose beyond mere temporal existence. Finally, the paradox of time pushes us to contemplate the relationship between humanity and the universe. Can we find a sense of connection in a cosmos where time is so ephemeral? The answer may lie in how we choose to live our lives in the quest for meaning within the vastness of the universe. Ultimately, the exploration of time and its relationship to the origin of the universe invites us to keep questioning, learning, and above all, marveling at the mysteries that still await discovery. The Big Bang was not only a monumental event that gave rise to everything we know, but it also marked the beginning of time itself. How is it possible for an event to create not only matter and energy, but also the concept of time? To understand this, it is essential to explore how time is conceived in the context of the universe. In our everyday experience, time is linear. We live in a sequence of moments, a past that we can no longer change, a present that constantly slips away from us, and a future full of possibilities. However, on the vast scale of the cosmos, time takes on a completely different meaning. Before the Big Bang, according to our current theories, there was nothing, neither space, nor time, nor matter. Everything was an absolute void. What does that mean for us? How can one comprehend a state in which time made no sense? Conventional narrative tells us that time began with the Big Bang. At this moment, all the space and matter that now occupy the universe were compressed into an infinitely small and hot point. As that singularity began to expand, time began to count from that instant. But what about the nature of time itself? Is it simply a measure of events? Or is it something deeper and more mysterious? We can imagine time as a flowing river. In this river, each moment is a drop of water. Before the Big Bang, there was no river, no drops, no flow. As the Big Bang occurred, the river began to flow, and with each passing drop, a new reality is created. In this sense, every event in the universe, every star that is born or dies, adds a drop to the river of time. But what if this river is not unique? What if there are multiple rivers, each representing different universes? The idea that the Big Bang created time leads us to reflect on the very nature of reality. If time is a dimension, just like space, could it be that there are dimensions of time that we have not been able to imagine? What if, in some corner of the multiverse, time flows differently? Imagine a universe where time moves backward, or where each moment is not a sequence but a cycle. In the journey of cosmology, we encounter questions that often seem to challenge our logic. Why does time seem to move forward with a clear direction? The second law of thermodynamics tells us that in an isolated system, disorder or entropy tends to increase over time. This could be the reason why we experience time as a linear flow, from order to disorder. But what implications does this have for the universe as a whole? If time began with the Big Bang, then the universe is like a book whose first page was written at that moment. Each episode in the history of the universe becomes a chapter, but what about the pages that have yet to be written? What future awaits us as the universe continues to expand? The answer may be as fascinating as it is perplexing. In this context, the question about the fate of time itself arises. As the universe expands, will there be a point at which time stops or transforms? Some scientists suggest that, in an expanding universe, time could slow down. Imagine a distant future where time feels like a whisper, where events become so rare that the perception of time distorts. The paradox of time also leads us to question the relationship between time and consciousness. If time is a construct that arises with the Big Bang, how does this affect our perception of reality? Human consciousness, with its ability to reflect on the past and anticipate the future, seems to have a unique relationship with time. Could it be that our consciousness is a manifestation of time itself, a mirror reflecting the flow of the universe? As we explore these questions, it becomes evident that time is not just an abstract concept, but an essential component of human and cosmic experience. It is a thread that connects our small corner of the universe with the vast fabric of the cosmos. Can we truly understand the origin of time if we do not first understand our own existence? The Big Bang, by creating time, also invites us to consider our role in the universe. We are temporal beings in a universe that, in turn, is a product of time. What does this mean for our search for meaning and purpose in such a vast and ever-changing cosmos? The answer to this question could be as diverse as the stars in the sky. As we delve into the mystery of time and its relationship with the origin of the universe, we find ourselves on a journey of discovery that has no end. Each new theory, each new experiment brings us one step closer to understanding not only the cosmos, but also ourselves. The story of time is intertwined with the story of the universe, and each discovery invites us to keep exploring and asking, what else will time reveal to us? What physical laws allowed for the creation of the universe? This is a fascinating question that leads us to explore the very foundations of existence. From the moment the universe began to expand, a series of laws and principles have governed its evolution. But how do we understand these laws, and what role do they play in the very creation of the cosmos? Physics, in its purest essence, seeks to unravel the secrets of the universe. When we think of creation, we often imagine an act of magic or an extraordinary event. However, the reality is that the creation of the universe is based on physical principles that are as intricate as they are surprising. For example, the force of gravity, which keeps us anchored to the Earth, was also responsible for the formation of galaxies, stars, and planets. Without gravity, the universe would be a chaotic place devoid of shape or structure. In addition to gravity, energy plays a crucial role in the creation of the universe. Einstein's famous equation, which relates mass and energy, tells us that everything we see and know has an associated energy. This energy not only fueled the expansion of the universe after the Big Bang, but also allowed for the formation of matter. So what does this mean for us? It means that we are all part of a vast fabric of energy that connects every corner of the cosmos. Creation is also linked to what we call conservation laws. These laws state that energy and matter cannot be created or destroyed, but simply transformed. In the context of the Big Bang, this suggests that all the energy and matter we know today were already present in a primordial form. So where was this energy before the universe expanded? This question takes us to the edges of our understanding, where physics meets philosophy. One of the keys to understanding the creation of the universe lies in symmetry. In nature, we observe recurring patterns, from the arrangement of leaves on a plant to the structure of galaxies. These symmetries are not mere coincidences. They are fundamental principles that guide how matter and energy behave. If symmetry is broken, as happens under certain extreme conditions, surprising phenomena can emerge. So what would happen if we could understand these symmetries at a deeper level? String theory also offers us an intriguing perspective on creation. According to this theory, subatomic particles are not points, but tiny vibrating strings. The way these strings vibrate determines the properties of the particles that make up everything we know. If we consider that the universe began as a primordial vibration, we realize that creation can be seen as a cosmic symphony. Who wouldn't marvel at the idea that everything in the universe is the result of a music that still resonates? The concept of time is another fascinating aspect of creation. Could it be that time itself began with the Big Bang? This idea challenges our usual understanding of time as a continuous line, suggesting that before the Big Bang, time as we know it did not exist. So what does this mean for our perception of the past and the future? It invites us to reconsider our relationship with time and how it affects our existence. The physics of creation also leads us to discuss dark matter and dark energy, essential components of the universe that we still do not fully understand. These mysterious entities not only make up most of the matter and energy in the cosmos, but also influence its expansion. If these forces are fundamental to creation, what other surprises might await us as we delve deeper into their study? In the quest for answers, the scientific community has conducted numerous experiments to test these theories. From the Large Hadron Collider to telescopes observing the early stages of the universe, each discovery brings us one step closer to understanding the laws that govern creation. How can we continue to unravel these mysteries in such a vast and incomprehensible universe? Reflecting on the physical laws that allowed for the creation of the universe leads us to consider our own existence. If we are the product of these laws, what do we mean in the grand scheme of the cosmos? We are observers in a universe that has existed for billions of years, and each of us is a manifestation of the same forces that gave rise to stars and planets. We might think of creation as an isolated event, but in reality, it is a continuous process. Every moment we live is a new manifestation of the laws of the universe. How do our everyday experiences relate to the grandeur of the cosmos? This intrinsic connection invites us to see the universe not just as a physical space, but as an environment in which each of us has a role to play. Science and philosophy often intersect in the exploration of the origin of the universe. As we delve into the laws of creation, we face existential questions about our place in the cosmos and the purpose of our existence. If everything is interconnected, could there be a deeper meaning behind our life in this vast universe? Finally, when considering the physics of creation, we realize that each answer leads to new questions. The pursuit of knowledge never stops, and each discovery in the field of science pushes us to keep exploring, questioning, and marveling. After all, the universe is a place full of mysteries, and each of us has the opportunity to be part of that great adventure of discovery. What new wonders await us on the horizon of our understanding? The answer is waiting to be discovered, and curiosity is the engine that drives us forward. Are there other forms of life in the vast universe, or even in parallel universes? This question has captivated the imagination of scientists, philosophers, and dreamers alike. The idea that we might not be alone in the cosmos is as intriguing as it is challenging. Michio Kaku, a leader in the field of theoretical physics, invites us to explore this fascinating possibility. In his vision of the multiverse, life could be more common than we think. Imagine an infinite ocean of universes, each with its own rules and conditions. In some, the stars shine differently, and in others the laws of physics could be completely distinct. What does this mean for life? If the universe is so vast and unpredictable, the existence of life in other corners of this reality seems not only possible but probable. The search for life in other universes raises profound questions about the very nature of existence. What is life? Is it simply a combination of atoms and molecules, or is there something more? Science has sought to define life, but there is still much we do not understand. In a universe where conditions can vary greatly, life could take forms that we cannot even imagine. In this context, the theory of multiverses suggests that life could manifest in ways that challenge our traditional notions. Think of it as if you were watching a series of movies. Each movie has its own plot, its own characters, and its own world. Thus, each universe could be its own movie, with different versions of life, adapting to their respective realities. The existence of multiple universes also opens the door to the idea that in some of them, life may have evolved under conditions that would be considered extreme in our universe. What about a world where water is not the fundamental component for life, but rather a completely different liquid? Or imagine a universe where life is based on silicon instead of carbon. The possibilities are endless. As we explore these ideas, it is natural to wonder if we will ever find evidence of life in other universes. This is where theoretical physics comes into play. Although we cannot directly observe other universes, scientists are developing models and theories that could allow us to infer their existence. Kaku, for example, has spoken about how quantum physics and string theory may provide clues about the nature of the multiverse. The concept of multiverses also invites reflection on the fate of life. If there are an infinite number of universes, does that mean that in some of them, even the decisions we make today could be different? It's an intriguing thought. Each choice could lead to a new universe where the outcome is completely different. Life, in this sense, becomes a cosmic experiment where each of us is a small universe in itself, but it's not just about the existence of life in other universes. It also raises questions about our own existence. If life is common in the multiverse, what does that mean for us? Are we here by chance, or is there a greater purpose in the cosmos? The answers to these questions are deeply philosophical and compel us to consider our connection to the universe on a deeper level. As science advances, the search for life elsewhere in the cosmos becomes increasingly accessible. Missions to Mars and explorations of exoplanets are just the beginning. However, the idea of life in other universes could be an even greater challenge. If there are universes that we cannot observe or explore, how can we even begin to understand what might exist there? Scientists continue to speculate about the conditions that would make life possible. Astrobiology, an emerging field, focuses on the search for life beyond Earth. From the oceans of Europa, a moon of Jupiter, to exoplanets in habitable zones around other stars, the search for life is an exciting journey. But what about those universes that are beyond our comprehension? The possibility that life exists in other universes also leads us to consider the diversity of human experience. If there is a universe where our choices are different, what would our lives look like in those alternative worlds? The idea that we might have taken different paths in other realities invites us to reflect on the importance of our decisions in this universe. Ultimately, the notion of life in other universes is not just a scientific question, but also an exploration of our place in the cosmos. It reminds us that, although we may sometimes feel alone, the universe is a vast and mysterious place. As we continue to explore and seek answers, perhaps one day we will discover that we are not as alone as we think. In the end, the search for life in other universes may be one of humanity's most exciting adventures, a quest that reflects our innate curiosity and our desire to understand the great mystery that is the universe. Human consciousness has been a topic of fascination throughout history. From Greek philosophers to contemporary scientists, the question of what consciousness is and what its relationship with the universe is has captured the imagination of many. Is it simply a byproduct of brain activity? Or is there something deeper that connects our mind with the cosmos? Michio Kaku, a prominent theoretical physicist and science communicator, invites us to explore this intriguing relationship between consciousness and the universe. When considering how consciousness may be linked to the vast universe, it is essential to remember that we are part of a much greater whole. Each of us is a collection of atoms that once formed stars. In a sense, when we look up at the sky, we are looking back at our own origin. But what does this mean for our understanding of consciousness? Could it be that we are connected in a way that transcends conventional physics? The notion that consciousness could be a fundamental property of the universe is an idea that Kaku has explored. Imagine that consciousness is not just the result of our biology, but rather a phenomenon that manifests in different forms throughout the cosmos. Just as there are different states of matter, could there be different states of consciousness? This question leads us to reflect on what it means to be conscious, and how that consciousness relates to the structure of the universe. The concept that consciousness could exist independently of physical matter is a topic that has been debated for centuries. Some philosophical currents suggest that consciousness is a primordial force, similar to gravity or electromagnetism. From this perspective, consciousness did not just emerge with life, but has been present since the beginning of the universe. If this were true, what implications would it have for our understanding of life and existence itself? Kaku also suggests that consciousness could play a role in creating our reality. In this sense, we might imagine that our perceptions and thoughts influence the world around us. Could it be that the universe is, in some way, a mirror of our collective consciousness? This idea resonates with concepts from quantum physics, where observation seems to affect the behavior of particles. So, the question is, could our consciousness be the key to unlocking the deepest secrets of the universe? Some scientists have begun to investigate the relationship between consciousness and quantum phenomena, attempting to understand how the human mind might interact with physical reality. This research raises a fascinating question. If our consciousness can influence the universe, could it be possible that, in some way, we are co-creating our own existence? The idea that the universe is in constant dialogue with our consciousness challenges traditional notions of cause and effect. Consciousness can also be seen as a thread that connects all living beings. In this sense, if we are all part of the same cosmic fabric, how does our consciousness influence the well-being of the universe as a whole? Kaku posits that, by being conscious, we have a responsibility toward the cosmos. Could it be that our actions and thoughts not only affect us, but also everything around us? Imagine a universe where consciousness is not just an isolated phenomenon, but an essential aspect of existence. If humans and other living beings are capable of perceiving and understanding the universe, this could mean that consciousness has a greater purpose. Could it be that evolution has been guiding consciousness toward a greater understanding of itself and the universe? The search for the connection between consciousness and the universe leads us to explore deeper questions about existence and meaning. If consciousness is, in some way, a manifestation of the cosmos, then each of us has a role in the grand drama of the universe. Could it be that conscious life is the means through which the universe observes itself? This idea suggests that every thought, every emotion, and every action has an echo in the vast tapestry of the cosmos. Kaku also reflects on how consciousness might relate to concepts of spirituality. In many spiritual traditions, consciousness is considered a sacred element, a link between the human and the divine. Viewing the universe from this perspective, we might begin to see science and spirituality as two sides of the same coin, both seeking answers to the great questions of life. The relationship between consciousness and the universe invites us to reconsider our own identity. If we are part of the cosmos, what does it mean to be human? Are we destined to transcend our physical limitations and explore new dimensions of existence? The idea that consciousness can evolve and expand presents an exciting future, where humanity could discover new ways to interact with the universe. Ultimately, the exploration of consciousness in the context of the universe is not just a scientific question, but also a philosophical journey. Each of us has the capacity to reflect on our place in the cosmos, and in doing so may find a sense of connection and purpose. In the grand scheme of the universe, our consciousness could be a beacon of light, guiding us toward a deeper understanding of our existence. Thus, in considering the relationship between consciousness and the universe, we find ourselves faced with a mystery that invites us to keep exploring. Human curiosity, that spark that drives us to seek answers, is perhaps one of the greatest gifts the universe has bestowed upon us. In this journey of discovery, every question we pose may bring us a little closer to understanding who we are and why we are here. Is it possible that all the laws of physics are connected in a great whole, like pieces of a cosmic puzzle? The search for a unified theory has captured the imagination of scientists and philosophers alike. Since time immemorial, we have tried to understand the rules that govern the universe. But why is it so important to unify these laws? The answer may seem complicated, but it is fundamental to unraveling the mysteries of the cosmos. Imagine you are playing a video game. Each level has its own rules, but in the end they are all interconnected. In the realm of physics, we currently have several parts of rules. Einstein's theory of relativity, which governs the behavior of extremely large objects, and quantum mechanics, which describes the world of subatomic particles. However, so far, we have not managed to piece those parts together coherently. Relativity and quantum mechanics are like two different languages that describe the universe but do not understand each other. How can an object as massive as a black hole behave differently from a small particle of light? This is one of the questions that has led researchers like Michio Kaku to explore the possibility of a unified theory. Kaku suggests that this union is crucial for understanding the nature of the universe as a whole. What would be the key to achieving that unification? One of the most promising theories is string theory. Have you ever played with threads and strings, trying to create shapes and patterns? In string theory, it is proposed that fundamental particles are not points, but vibrating strings. These strings can vibrate at different frequencies, and the way they vibrate determines the properties of the particle. This idea could offer a path toward the unification of all the forces of nature. But how does this relate to the origin of the universe? If all forces are interconnected, that means the very Big Bang that created the universe may have also established the rules that govern it. So, In searching for a unified theory, we are not only trying to understand the present but also the past. What happened in those initial moments that gave rise to our cosmos? The answer could be hidden at the intersection of relativity and quantum mechanics. The concept of unification also raises fascinating questions about the fate of the universe. If we come to understand how to unify the forces, we might be able to predict the future of the cosmos. Are we doomed to an eternal fading, or is there a cycle of creation and destruction? Each discovery in this quest brings us one step closer to unveiling the mystery of time itself. Consider the example of a conductor. Each musician has their own instrument and their own sheet music, but the conductor manages to make them all play in harmony. In physics, the role of the conductor is the unified theory. If we manage to find it, we could understand how all the forces of the universe interact, and how those interactions have shaped the reality we know. What if I told you that the answer to some of the deepest questions about the origin of the universe might lie in experiments that have yet to be conducted? In the quest to understand how everything began, scientists have devised fascinating methods to test our theories about the Big Bang and the expansion of the universe. Each experiment is like a window that allows us to look back in time to that primordial moment. One of the most intriguing experiments is the use of particle colliders, such as the Large Hadron Collider. Imagine that these colliders are like enormous laboratories where conditions similar to those of the early universe are created. In this space, tiny particles collide at incredible speeds, generating chaos that could replicate the energy and conditions that existed just after the Big Bang. Could it be that by observing these collisions, we are witnessing fragments of the universe's creation? The question that arises is, what can we learn from these collisions? By studying the particles resulting from these explosions, scientists can gain clues about dark matter and dark energy, those mysterious entities that make up most of the universe. It's like finding pieces of a cosmic puzzle that we were missing, and each new piece we fit brings us a little closer to understanding the whole. In addition to colliders, there are telescopes that look deep into the cosmos. Have you ever wondered what secrets distant galaxies hold? With telescopes like Hubble, scientists are collecting data that tells us the story of how the first stars and galaxies formed. By observing light that has travelled for billions of years, we can see the universe as it was in its early moments. It's as if we have the opportunity to read a book that speaks of the cosmos' childhood. On the other hand, there is also the study of gravitational waves. These ripples in the fabric of space-time were predicted by Einstein, and their detection has opened new doors in cosmology. What do these waves tell us about cataclysmic events, such as black hole collisions? Each time one of these waves is detected, we are offered a new way to look at the universe, as if we are tuning into a station that broadcasts the stories of its origins. Computer simulations also play a crucial role in our search. Scientists create models that simulate how the universe would behave under different conditions. What would happen if we altered the laws of physics in those models? Through these simulations, we can experiment with the variables that might have influenced the evolution of the universe, exploring alternative scenarios that challenge us to think beyond the known. Each of these experiments has a clear purpose: to validate or challenge existing theories. But what happens if a theory does not hold up? Science advances through doubt and constant revision. Every time an experiment yields unexpected results, it opens up new questions. This is how knowledge is built, through curiosity and constant questioning. One fascinating aspect of these experiments is that they are not only designed to answer questions, but they also raise new ones. When we discover something new, we often realize that there is even more that we do not know. This is the nature of science, an endless cycle of discovery and uncertainty. Who knows what new surprises await us on the horizon? The interconnection between theory and practice is fundamental. Experiments not only test ideas, but they also inspire new theories. Every time a scientist observes something that does not fit with their current understanding, a path opens up to new questions and new possibilities. In this sense, experiments are like a dialogue between theory and the universe. International collaboration is also key in this quest. With scientists from all over the world working together, each experiment becomes a collective effort. This synergy allows us to share knowledge and resources, accelerating the discovery process. Isn't it amazing to think that our understanding of the universe could be in the hands of a team that spans continents? Finally, each experiment conducted is not just an attempt to understand the past, but also to prepare us for the future. By understanding how the universe formed and evolved, we arm ourselves with knowledge to face questions about our own place in it. What is our role in this vast cosmos? Are we alone in this immensity? So as we look up at the starry sky, let us remember that each star we see is a reminder of the story we are trying to unravel. The experiments being conducted today are the foundations of tomorrow's cosmology. Each discovery brings us a little closer to unveiling the mystery of the universe, and perhaps to understanding who we truly are in this incredible cosmic adventure. Modern cosmology has transformed our understanding of the universe in an astonishing way. From the moment scientists began to explore the far reaches of the cosmos, discoveries have been made that challenge our conception of reality. How can it be that something as vast and complex as the universe has such a specific origin? The answer to this question lies in the evolution of cosmology over the decades. One of the major advances in this field was the formulation of the Big Bang theory. However, that is just the tip of the iceberg. As we have delved deeper into the study of the universe, we have realized that there is much more at stake than we initially thought. What lies behind the expansion of the universe, and how is it related to the creation of everything we know? Telescopes have played a crucial role in this development. But did you know that they not only look into space, but also look back in time? Every time we observe a distant star, we are seeing its light as it was millions, even billions of years ago. This phenomenon allows us to glimpse the early moments of the universe and understand how it has evolved since then. Modern cosmology does not stop at Big Bang. It also leads us to concepts that seem straight out of science fiction, such as dark matter and dark energy. How is it possible that most of the universe is composed of something we cannot see or touch? This idea may seem perplexing, but it is fundamental to explaining the structure and behavior of the cosmos. These mysterious components not only influence how galaxies move, but are also essential for understanding the accelerated expansion of the universe. And speaking of expansion, what does it really mean that the universe is constantly expanding? Imagine a balloon being inflated. Every point on the surface of the balloon moves away from the others as air is introduced. This simple example illustrates how galaxies are moving away from each other. As the universe expands, new questions arise. What lies beyond the edges of the observable universe? Could there be other universes outside our own? Cosmic inflation is another key piece in this puzzle. This theory suggests that, in a very brief moment after the Big Bang, the universe experienced an incredibly rapid expansion. But why is this fleeting moment important? Understanding inflation helps us comprehend how the structures we see today formed, from galaxies to galaxy clusters. It's like understanding how a landscape formed from a whirlwind of dust. Furthermore, how does symmetry relate to the origin of the universe? In the physical world, symmetry is a powerful tool that helps scientists formulate laws. Kaku reminds us that the beauty and harmony we find in the laws of physics might be intertwined with the very fabric of the cosmos. This connection between symmetry and the origin of the universe raises fascinating questions about the nature of reality itself. String theory, one of the most intriguing proposals in modern physics, takes us even further. Imagine that subatomic particles are not just points, but vibrating strings of energy. The way these strings vibrate could be the key to unifying all the forces in the universe. Could a deeper understanding of these strings help us unravel the mystery of the origin of the universe? And if we consider the idea of multiverses, the possibilities multiply. If other universes exist, what would that mean for our understanding of life in the cosmos? Could we be just one of many cosmic experiments? These questions have led to philosophical and scientific debates that continue to challenge our notions of existence and reality. As we advance in the exploration of the universe, the paradox of time becomes an inevitable topic. If the Big Bang created time, what was there before it? Is it possible that time is just an illusion of our perception? These reflections lead us to question our own existence and the role we play in the vast stage of the cosmos. The physics of creation is also a fascinating area. The laws that govern the universe not only allow for its existence, but could also offer clues about its purpose. Could there be an underlying design behind everything we see? This type of questioning opens a space for discussions about science and spirituality. Finally, current and future experiments promise to take us even further in our quest for answers. From the Large Hadron Collider to gravitational wave observatories, each new tool brings us closer to the truth about the universe. As technology advances, so does our understanding, and each discovery leads us to new questions. Modern cosmology, with all its complexities and wonders, shows that the universe is a place full of surprises. Each discovery not only offers us a new perspective on the cosmos, but also invites us to reflect on our place within it. The pursuit of knowledge is an endless journey, and as Kaku aptly states, the exploration of the universe is an adventure that we are just beginning. The origin of the universe raises questions that have fascinated humanity since time immemorial. What lies beyond our existence? What does the Big Bang really mean for our understanding of the cosmos? These questions not only lead us to explore physics, but also open a vast field of philosophical reflection. Science and philosophy in this sense are two sides of the same coin, and each discovery in cosmology forces us to rethink our conception of the world. How does our understanding of the origin of the universe affect our identity as human beings? When we look at the starry sky, are we merely spectators, or is there a deeper connection? The idea that everything we know comes from a cosmic explosion over 13 billion years ago leads us to question our place in the vast fabric of space and time. If the universe is so ancient and vast, what does that mean for our daily lives? Each of us is the result of a long chain of events that began in that primordial moment. The concept of time itself transforms when studying the origin of the universe. Is time a straight line that moves indefinitely, or is it rather a cycle in which everything is interconnected? Kaku suggests that the Big Bang not only created the universe, but also established time as we know it. This raises a troubling question. If time began with the universe, what was there before the Big Bang? Some theories suggest that time could be an emerging phenomenon, a product of interactions in the cosmos. This leads us to question the very nature of existence. Philosophy also invites us to reflect on purpose. If the universe arose from nothing, is there a meaning behind its existence? Are we here by accident, or is there a larger design at play? The big questions of life, such as the search for meanings and purposes, arise from the same curiosity that drives scientific inquiry. Kaku highlights that science and spirituality can coexist, each bringing its own perspective to the human experience. Considering the possibility of multiverses, philosophy delves into even more intriguing territory. If multiple universes exist, each with its own realities, what does that mean for the concept of free will? Are we truly making decisions, or are our lives simply a manifestation of a set of infinite possibilities? This notion can be disconcerting, but also liberating. It invites us to see our lives as part of a vast web of realities, where each choice can open new doors. The study of dark matter and dark energy also leads us to deepen our beliefs about the universe. If these forces are responsible for most of the cosmos, what does that say about our understanding of reality? Science teaches us that there is much more than what we perceive with our senses. The quest to understand the invisible pushes us to accept that there are limits to our perception, and that reality may be much more complex than we imagine. How do science and ethics relate in this context? As we advance in our understanding of the universe and its origin, we also face ethical dilemmas. The manipulation of nature and the use of technology to explore the cosmos raise questions about our responsibility. Are we prepared to handle the power that comes with knowledge? The decisions we make today could have repercussions on how we interact with the universe in the future. The relationship between consciousness and the universe is also a topic worthy of exploration. Is consciousness merely a byproduct of evolution, or is it something deeper? Some philosophers suggest that consciousness is a reflection of the universe itself, an attempt to understand itself. This connection leads us to consider the possibility that we, as conscious beings, may have a role in the fabric of the cosmos. Could it be that our search for answers is, in itself part of the creative process. The dialogue between science and spirituality also invites us to consider the beauty of the universe. The nature of physical laws and the wonders of the cosmos are not only subjects of study, but also evoke awe and reverence. Science can offer explanations, but the experience of cosmic beauty can touch us on a deeper level. Could it be that the pursuit of knowledge and the appreciation of beauty are two paths that lead us to the same truth? As we progress on this journey of discovery, it is vital to remember that questions are as important as answers. Curiosity drives us to continue exploring the mysteries of the universe. Kaku reminds us that, in facing the unknown, we are also challenging our own beliefs and expanding our consciousness. Every answer we find opens new questions, and it is in that space of inquiry where the true essence of humanity resides. Finally, the exploration of the origin of the universe invites us to be part of something greater than ourselves. It reminds us that we are fragments of a vast whole, connected through time and space. In this quest to understand our place in the cosmos, Kaku and other scientists show us that science is not just a series of theories and formulas. It is a shared journey toward understanding, a path that we can all walk together, where each of us has a role to play in the history of the universe. What place does spirituality occupy in a universe that seems governed by strict physical laws? In addressing the relationship between science and spirituality, Michio Kaku invites us to reflect on how these two dimensions can coexist and complement each other. Science, with its focus on observation and experimentation, seeks to unravel the secrets of the cosmos. On the other hand, spirituality offers us a sense of connection and purpose amidst the vastness of the universe. In this context, an intriguing question arises. Can science provide answers to questions that have traditionally been considered within the realm of spirituality? Kaku suggests that, in many cases, science can illuminate aspects of our existence that once seemed unreachable. For example, by understanding how stars and galaxies formed, we can appreciate the beauty of the cosmos in a way that touches our souls. The fascination with the universe resides not only in its laws and formulas, but also in its capacity to inspire awe. The idea that the universe has a purpose or meaning has been a topic of debate for centuries. Some argue that, by observing the complexity of life and the order of the cosmos, the existence of a larger plan is suggested. However, Kaku reminds us that science, while powerful, does not necessarily answer the question of why. While it can explain how, the search for purpose may be a more personal and subjective journey. Scientific theories about the origin of the universe, such as the Big Bang, lead us to reflect on our own existence in a vast and unpredictable cosmos. What place do we occupy in this immensity? Kaku proposes that, by understanding our environment, we approach a form of knowledge that transcends the material. It is not just about facts and figures, but about the narrative of humanity within a constantly expanding universe. The quest for answers about the universe can also offer comfort. In facing the uncertainty of life and death, science provides a framework that can reconcile with spiritual beliefs. Kaku suggests that, instead of viewing science and spirituality as opposites, we can find common ground where both enrich each other. For example, the notion that we are stardust could be interpreted as a reminder of our connection to the cosmos, resonating with many spiritual traditions that emphasize the interconnection of all that exists. The question of whether consciousness has a place in cosmology is often raised. Is it merely a byproduct of evolution, or is there something more? Kaku posits that consciousness could be a fundamental property of the universe, akin to gravity or electromagnetism. This idea suggests that, in a profound sense, we are interconnected with the cosmos in ways we do not yet fully understand. This opens a space for spirituality and science to dialogue about the nature of reality. The concept of multiverses also invites reflection. If infinite universes exist, each with its own laws and realities, what does that imply for our understanding of life, purpose, and spirituality? Kaku challenges us to imagine a cosmos where every decision and possibility manifests in different dimensions. This may seem daunting, but it can also offer a liberating perspective, where each life has its own value and meaning in a vast web of realities. Science has made considerable advances in exploring these concepts, but Kaku emphasizes that much remains to be discovered. The intersection between science and spirituality can be seen as a fertile ground for future research and reflection. How can we integrate this knowledge into our daily lives? Curiosity, openness, and a willingness to question our own beliefs become valuable tools on this journey. In the search for answers, the dialogue between science and spirituality can enrich our understanding of ourselves and the universe. By opening ourselves to new ideas, we can find a deeper sense of belonging and purpose in the vast web of existence. Science offers us a map, while spirituality invites us to explore the landscape of our emotions and experiences. Kaku also suggests that our capacity to be amazed and wonder at the universe is, in itself, a spiritual act. Human curiosity about the cosmos, the quest for answers to fundamental questions, and the appreciation of the beauty of the universe can be seen as a form of spirituality. This connection to the unknown reminds us that, although we may unravel many of the mysteries of the universe, there will always be more to discover. The relationship between science and spirituality is not a dichotomy, but a spectrum where both can coexist and complement each other. Science provides us with tools to explore the universe, while spirituality offers us a context to reflect on our place within it. In this sense, the journey of understanding can be both scientific and spiritual, and Kaku invites us to embark on this odyssey with an open mind and receptive heart. At the end of the day, the deepest question we can ask ourselves is, what does it mean to be human in such a vast universe? The intersection between science and spirituality may offer us some answers, but it also raises more questions. What is important is that the pursuit of knowledge, whether through science or spirituality, is an essential part of our experience as human beings, a journey worth undertaking. The origin of the universe is a topic that has fascinated humanity since time immemorial. As we have advanced in our understanding of the cosmos, we have begun to ask increasingly profound questions. What lies beyond what we see? Why is there something instead of nothing? These questions may seem philosophical, but they are also the driving force of science. The search for answers pushes us to explore the mysteries of the universe, and along that path, figures like Michio Kaku become exceptional guides. The idea that the universe has a beginning and a fascinating history changes our perception of reality. Instead of viewing the cosmos as a static and eternal place, we understand it as a dynamic stage, constantly changing. As we reflect on the Big Bang, the consideration arises that this event not only created stars and planets, but also marked the beginning of time itself. But what does this really mean for us? It invites us to rethink our existence and our place in the vast universe. Human curiosity leads us to wonder if we are alone in this vast cosmos. The possibility that other universes exist, with their own realities and forms of life, challenges our understanding of what it means to live. Could there be versions of ourselves in those alternate worlds? This idea of multiverses, as intriguing as it is perplexing, offers us a new perspective on life, consciousness and destiny. The relationship between human consciousness and the universe is another fascinating aspect to explore. Are we here by chance, or is there a deeper purpose to our existence? Kaku suggests that consciousness could be an integral part of the structure of the cosmos, implying that perhaps we are not mere observers but active participants in a grand cosmic spectacle. This viewpoint invites us to consider how our actions and thoughts may be intertwined with the very fabric of the universe. The quest for unification in the laws of physics resonates with the idea that everything is connected. As scientists work to understand how different theories fit together, from relativity to quantum mechanics, new questions arise about the origin of the universe. Could there be a single law that explains everything? This yearning for unification reflects our search for meaning and order in a universe that often seems chaotic and unpredictable. The philosophical implications of these discoveries are profound. They compel us to rethink our understanding of reality, existence, and our role in the universe. If everything is interconnected, what does that mean for our relationships and our decisions? Each scientific discovery adds a layer of complexity to our lives and at the same time offers us the opportunity to find a deeper sense of purpose. Science and spirituality, often seen as opposites, can coexist in this context. Kaku suggests that by understanding the universe through science, we can also approach spiritual questions about purpose and existence. Science does not necessarily eliminate wonder, rather it can deepen it and enrich our experience of life. The history of the universe, from the Big Bang to the evolution of life, is an astonishing narrative that invites us to be part of something greater than ourselves. Every star in the sky, every atom in our bodies, is the result of a cosmic process that has taken billions of years. This sense of connection with the universe can inspire us to care for our planet and seek a future where life thrives in harmony with the cosmos. Ultimately, Kaku's invitation is to keep exploring. Every question we ask and every answer we find brings us one step closer to unraveling the mysteries of the universe. Even if we never have all the answers, the journey itself is what matters. Curiosity and the desire to understand are what drive us to move forward. As we look to the future, we may wonder how science will continue to transform our understanding of the universe and ourselves. What new theories will emerge? What revolutionary experiments will change our perspective? The history of the universe is far from over, and we are part of that ever-evolving narrative. With each advance in science, we are reminded that the universe is a place full of wonders and mysteries. The beauty of the cosmos lies not only in its vastness, but also in our ability to marvel and question. The pursuit of knowledge is a journey without end, and each of us has a role to play. So, as we close this chapter on the origin of the universe, let us remember that each discovery is a step on an endless staircase. Human curiosity is a driving force that propels us forward, and the exploration of the cosmos is one of the most exciting adventures we can undertake. Let us keep asking, keep exploring, and above all, keep dreaming.